Chapter 5, 5.2. We're continuing on working on normal distribution. Very well. Our goal in 5.2 is to find the probability for normal distribution. Very well. When you have a normal distribution for a continuous variable, following a normal distribution, instead of having a histogram, we can actually have very small bars. We connect these bars together and form a nice and smooth graph. This is a continuous graph. We learned that if we have a normal distribution, mean, mode, median, all of them are the same and they are on horizontal line, a number on the horizontal line with the highest frequency. So the center is the same. It's either the mean, the mode, or median. Then we saw that we can find the probability using the area below the graph. To use a normal distribution function or ZTable, we have to convert X values into Z values. Our X as original data was 500. Converting 500 into Z, you get 0 as the center or mean or median or the mode. What is our goal? Our goal is to use ZTable. That's why we have to convert everything into Z. We're not working with original data. We're working with ZTable, Z values to find the probabilities. Very well. Let us take a look at one example to feel more comfortable what's going on here. Example 1 says, a survey indicates that people keep their cell phone an average of 1.5 years. Okay, let us stop. The average, what's the meaning of average? Average means mean. So mean of the data is 1.5 years. Let us move on to second line before buying a new one. Okay, the standard deviation is 0.25. So standard deviation is also given. We have these two pieces of information. These are important information and we just write them here. Next, a cell phone user is selected randomly. Randomness is very important. To avoid bias, we have to use random process. Find the probability that the user will keep his or her current phone for less than 1 year, before buying a new phone. Assume that the lengths of time people keep their phone are normally distributed. So this line assures us the graph is bell-shaped. Very well. So first of all, you have to assign a variable like X. You're looking for the probability that X is less than 1 year. What is this probability? This is our goal, to find the probability or to find the area below the graph. Okay, less than 1 year. First of all, this is X. Since it's X, we cannot use ZTable. ZTable is all about Z values. It's not about X values. We cannot use ZTable. What's the remedy for that? Okay, we know how to convert X into Z. Z is equal to X minus mean divided by standard deviation. We learned about this formula and we use it to convert X into Z. We know that X is 1, so 1 minus the mean, which is 1 point, let me see, 1.5, yeah.
1.15.
Typo here. Let us fix this. Perfect. 1.5 divided by 0.25. Perfect. If we do the algebra, the outcome is equal to -2. So we found our Z, which is -2. And since it says less than on the left-hand side of Z, we're finding the probability that Z is less than -2. Now you can use ZTable to find the probability. So let us look for a good ZTable. Okay, let me share the screen with you. I'm browsing a good ZTable. ZTable PDF. Okay. Let's use ZTable from Arizona University. Let's put it in the desktop. Okay. Perfect. Let us share PDF with you. On the left-hand side of -2. So your goal is to find the probability that Z is less than -2, which is equivalent saying that P of X less than P of X less than 1 year. These two are equivalent to each other. But remember, we don't have any table for X. We only have table for Z. So we have to convert X to Z and then use the table. Okay. -2. If you assume the decimal, it means that you have 0 and 0 in front of the decimal. Okay. -2.0, the first two digits on the first column, -2.0, it's just right here. And the last digit is 0, which is on the first row. So the intersection between these two is going to be very small. 2%, almost 2%. So the probability is 2%. That's how we use our ZTable. Guys, move on to next page. Next, another example. So let us read this example line by line. A survey indicates that for each trip to supermarket, a shopper spends an average 45 minutes. What's the meaning of that? It means that the mean is equal to 45 minutes. This is your mean. Standard deviation is also given, 12 minutes. So standard deviation is 12 minutes. The lengths of time spent in the store are normally distributed. So this one assures us that we have a bell curve graph and are represented by variable x. A shopper enters the store. First of all, find the probability that the shopper will be in the store for each interval of time listed below between 24 to 54 minutes. So first x is 24, second x is 54. Question A, part 1 is asking to find the probability that x is between 24 minutes to 54 minutes. Can we use ZTable? We cannot use ZTable right now. Why? Because it is x. First, we have to convert each of these x values into z values. Then we use the table 2 times. So remember that z formula is x minus mean divided by standard deviation. Here you have 2 x values, so you have to find 2 z values. Z sub 1 is equal to x, which is 24, minus mean, which is 45, divided by standard deviation, which is 12. We do the calculation, we find the first z value. Now you can go back to your table and find the probability that your value is less than negative 1.75. So negative 1.75. So let us take a look at our ZTable. Negative 1.74. Okay. 1.74. So my z is negative 1.7 and 4. The first 2 digits, negative 1.7 on the first column and 4 on the first row. Negative 1.7 is here, 4 is here. The intersection between these two gives us the probability or area. 0.04093. This is for the first z value.
Isn't it 1.75?
Is it 5? I made a mistake. Yeah. Okay.
I think so.
Thank you. Yes, yeah. It is 5. I made a mistake.
It's okay.
Okay, here we have 5. The intersection between these two which is the probability or the area. 0.0406. Perfect. Next z-value. You have two x values. So the second z-value is x, which is 54, minus the mean, which is 45, divided by sigma, which is 12. If you do the calculation, you get a positive z-value. So now you look at the table. So table 0.75. It's a positive number, so we have to use the second table, z 0.75. We're finding the probability that z is less than 0.75. 0.75. The digits around the decimal, 0.7. So we're looking for 0.7 on the first column. And the second digit on the right-hand side of the decimal, on the first row, 0.05. The intersection between these two gives you the probability or area, which is 0.77337. Now let us get back to the note. It says in between. Here you have two areas, two probabilities. You subtract them to find the area in between or the probability that your z is between these two numbers, or equivalently, x is between these two numbers. So the probability is almost 73%. Very well. 2 says, what's the probability that x is greater than 39 minutes? 39 minutes. Okay, this is x. Again, we cannot use ZTable. First, you have to convert your x into z to use ZTable. So we're following the same formula. Z is x minus mean divided by standard deviation. Your x is now 39, so you have 39 minus the mean, which is 45, over sigma, which is 12. If you do the calculation, the outcome is negative 0.5. Very well. Now you use the table, so you calculate your z, then you use the table. So let's take a look at the table, 0.05. It's a negative number. So let us erase these. 0.05. Okay, very well. Negative 0.5, and you can add another 0. The first two digits around the decimal on the first column, and the second digit on the right-hand side of the decimal is going to be on the first row. Okay, 0.05. You have to go further down. 0.05, which is here. And the last digit is 0. So the intersection between them is going to be this decimal number, 0.30854. That's the probability on the left-hand side of z. 0.30854. Let us get back to the note. So remember that question says, minimize this. Question says more than, greater than P of X to be greater than 39. Remember yesterday we said if it says greater than, you have to do a little bit of algebra. 1 minus the probability from the table. So 1 minus 0.3085, which is almost 70%, is your answer. Table only gives the area to the left-hand side. To find the area or probability on the right-hand side, you have to subtract the area in the table from 100%, which is 1. Let us continue to example 3.
Professor,
Okay.
quick question.
Yeah, go ahead.
Are we going to do the interpretation or we're not going to do that?
So the meaning of that is when 200 shoppers enter the store, you would expect 138 or about 138 shoppers to be in the store more than 39 minutes. So
Perfect.
the probability times the total number of people is going to be the calculation.
Perfect. Thank you.
Yeah, sure. So here you have 200. So the calculations for these probabilities are just for 1%. So if you have 200 shoppers, you multiply 200 by the probability, which is now, let's see, almost 70%. If you multiply them, you get 128 people. Perfect. So in example 3, we're going to use technology to find the normal probabilities. Triglycerides are a type of fat in the bloodstream. The mean triglyceride level in the United States is 134 milligrams. Okay, 134. The mean is given. Mean is 134. Assume the level, the triglyceride levels of the population of the United States are normally distributed. It assures us we have a bell-curved graph and we actually can use the ZTable with a standard deviation of 35. So standard deviation is also given. You randomly select a person, just one person. What is the probability that person's triglyceride level is less than 80? So you're looking for the probability that X is less than 80. Can we use ZTable? Of course not. First, we have to convert X into Z. Today, we're going to use our calculator to feel comfortable using it and find the probability for Z values. First of all, press second, then bars to get the distribution. Select normal CDF, then press enter. So here you have left boundary, right boundary, the mean, and the standard deviation. To the left, to the right, mean, and standard deviation. For example, here our mean is 100 and standard deviation is 15. The lower limit it gives you the area between these two numbers, 85, for example, and 115. Note that if one of the boundaries is infinity or negative infinity, we use 1e to power 99, or we use negative 1e to the power 99. Again, in this case, in this example here, in the instruction, it gives you the area between 85 and 115 with mean 100 and standard deviation 15. In our example, in the note, the left-hand side is toward negative infinity. So on the left-hand side, you have to use negative 1e to 99. By using your calculator, you can find the area to the left-hand side to be almost 6%. So you can use negative 10,000 on the left-hand side, 80, which is your x. So let me just move this a little bit up so you see the values. We are looking for the area, the probability on the left-hand side of 80 with mean 134. So this is your 80. This is the area to the left-hand side of 80. On the left-hand side, the lower boundary you can write as negative 10,000. Right boundary is 80. Mean is 134. And your standard deviation in the question is 35. Standard deviation. Then you enter. The area is going to be almost 6%. Question. What if the question says, find the probability that x is greater than 80? What should I do? How do I use my calculator? I know calculator just gives me the area, the probability to the left-hand side. To use your calculator, you write 1 minus 1 minus normal CDF, and you enter this information.